All right, we have wrapped up our operations with integers, our positives and negatives, and we're going to wrap up chapter 2 with graphing in 4 quadrants. So we're going to take the coordinate plane that we talked about earlier, and now we're going to expand it into the full coordinate grid. And again, the coordinate grid extends in all directions, so it includes negative values, even though the graphs we've been working with have typically been more of the positive values. So we're going to talk about quadrants today, and that's one of the 4 equal sections of the coordinate plane. So if you think of the x and the y axis, they kind of divide the coordinate grid or the coordinate plane into 4 equal parts, and each one of those parts is called a quadrant. And each quadrant is numbered 1 through 4 very creatively. So I'm just going to run through those basic parts of the coordinate plane right now. The upper right quadrant, where it's positive, positive, is quadrant 1, and we number these with Roman numerals, not regular numbers. We number these with Roman numerals, so that's always going to be positive, positive. So if you have an ordered pair that's 2 positive numbers, that is always going to live in quadrant 1. And then we continue counterclockwise around the grid. Here in the upper left, we're going to have quadrant 2, and that's going to be any ordered pair that's a negative number for the x value and a positive number for the y value. So negative, positive is going to put you in quadrant 2. And then lower left is quadrant 3. That's going to be 2 negative numbers. So if you have a negative, negative ordered pair, that's going to put you in quadrant 3. And then the lower right-hand corner is quadrant 4, and that will be a positive number followed by a negative number. So a positive x value and a negative y value will give you quadrant number 4. So let's take a look at some ordered pairs here, and let's name the coordinates of each point and identify the quadrant it is in. So just for easy reference here, so we don't have to flip back to the other screen, this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. So J is right here, and the coordinates of J would be -4, 4 to the left, and 3 down. So -4, -3, and that puts us in quadrant 3. Again, using the Roman numerals there. K is over here, and that is at -5, 2. -5, +2, and then that puts us in quadrant 2. L is down here, and that is at 2, -2, and that is quadrant 4. And then M is here at 0, 5. Now this is interesting. Where or what quadrant is M located in? It's kind of in between 1 and 2, so we might be tempted to say 1 and 2, but it's actually in neither. If you're on one of the axes, if you're on the x-axis or the y-axis, you are not in a quadrant, so we would say no quadrant, or more specifically, we'll just say it is on the y-axis. So we'll indicate what axis it's on if it's not in a quadrant. So that's locating points and identifying what quadrant they're in. And then here we're going to do the reverse. We're given the quadrant, or the coordinate, sorry, and we have to plot it or graph it and then identify what quadrant it lies in. So H is at 4, -3, so that's 4 to the right and 3 down. That's going to be right here. Here's H. And what quadrant is that? That is quadrant 4. Hopefully you said quadrant 4. And then I is at -1, 4. So it's 1 to the left, 4 up. There is point I, and that is quadrant, you got it, 2. J is at 0, -2, straight down. And again, we run into that situation there where it is not in a quadrant. It's on the y-axis. And K is at -2, -4, -2 to the left, 4 down. There's K, and that is quadrant 3. And then L is at 1, 2, that's 1 to the right and 2 up. There's L, and that is quadrant 1. So identifying points, plotting points, graphing points, and putting them in, or identifying the correct quadrant that they're in. And then lastly, we want to talk about graphing an algebraic relationship. So if you remember the rules that we talked about before in chapter 1, the equations we wrote, the tables and graphs. So again, we're going to kind of come back to that concept of equation, table, graph, words, equations, tables, graphs. Again, we want to try to keep introducing those concepts because we're going to really need those later on in this course. So the sum of two golf scores is 3. If X represents one score and Y represents the other score, make a table of possible values for X and Y, and then graph the ordered pairs and describe the graph. So the equation looks like this. The sum of the two numbers is 3, so X plus Y equals 3. So now we just need to come up with any two numbers that add up to 3. And since we're talking about the 4 quadrants here, I'm going to use some negative numbers. So if X was a -2, you can have a golf score of -2. What was the other golf score? Well, -2 plus 5 is 3. Could have -1 and 4. Those add up to 3. I could have 0 and 3. I could have 1 and 2, or I could have 2 and 1, and so on. So there's lots of different ways we can come up with a score of 3 in two golf scores, but these seem to be probably the most realistic or reasonable ones. And then if we plot these ordered pairs, -2, 5 is right here. -1, 4 is right here. 0, 3 is here. 1, 2, 2, 1, and so on. And we could have continued on. 3, 0 is a possible ordered pair as well. 4, -1, and 5, -2 also could have been in the table that fit on the graph. So describe this graph. Well, it seems to be decreasing or going down from left to right in a nice straight line. So again, these ordered pairs fall in a straight line. So using the 4 quadrants, negative numbers, negative integers, and algebraic relationships. So we're kind of just tying that all together here to wrap up chapter 2.